This is Chapter 5 Loops, Programming Exercise 20. Display prime numbers between 2 and 1000. Display all of the prime numbers between 2 and 1000 inclusive. Display 8 prime numbers per line. Numbers are separated by exactly one space. Alright, so the first thing we gotta understand is, what is a prime number? Well, prime number is basically a whole number that cannot be made by multiplying other whole numbers. Here's a list of all the prime numbers up to 1000. So the very first number, 2, is a prime number. 3, 5, 7, they're all prime numbers. Basically, you can't get these prime number by multiplying two numbers, two different numbers beside 1 and itself. So 1 times 2 gets 2, but you can't get any other numbers to multiply, any other whole numbers to multiply to get 2. Let's take a look at 41, for example, right? Let's say 7 times 6 will get us 42, and then maybe 7 times 5 will get us 35, but no two whole numbers multiplied together will get us 41 beside 1 and the number itself. Right, so that is a prime number. So how do we solve for a prime number through programming? Well, let's take, for example, we have 211, right? We will use the number, we'll start from 2, and then we'll go all the way to the square root of 211. And we'll use the number 2 to try to divide into the prime number or the number that we're given. And if we can't find any number that is 2 or all the way to the square root of 211, which is 14.5, then that number is a prime. Now, for example, this is supposed to be 211, but anyway, we'll see if 2 goes into 211, 3, 4, 5, all the way to 14. Does any of these number, 2 to the square root of 211, go into this number? And if it doesn't evenly go into this number, then this number is a prime. All right, so let's get a better visual through code. Let's try to code that, and let's try to understand how that works. All right, now before we code it, let's try to understand how we're going to code it, right? Now, like I mentioned before in this slide, it may not be a very visually representative of what I'm trying to do, but if you try to understand, I'm given this number, and then I'm trying to find if this number is a prime. Well, to find if this number is a prime, I'm going to have to start from the base possible number, which will not be 1, because we know that 1 and number itself goes into the number, but any number in between, we use it. If it goes into this number, then it's not a prime. If there are no number, then it is. So the best way to do this is through a loop. We're going to have to loop through 2 all the way to the square root of that number. So the best possible loop we could use could be a while loop or for loop, right? Those are only two options actually to tackle this. And we also have to remember, what kind of question are we being asked? Well, simply enough, we're just being asked 2 to 1000. Find the primitives between 2 to 1000. And I have a reference here to verify if it is correct, right? Number from 2 to 1000 that are prime. Okay, 998 is not a prime because it's divisible by 2. Same with 999 is divisible by 3. 1000 is divisible by 2. So they're not prime, and they do not appear on this list. So back to our question, 2 to 1000. So let's actually use a for loop. So for a for loop, where I'm going to start is I'm going to use the short data type. Short data type, let's call the variable name for this short data type a possible prime, right? And I'm going to start at 2 all the way to 1000. Less than or equal to 1000, right? Inclusive. And then possible prime plus plus, so incremented by 1 every time. I'm going to go from 2 to 1000. And I'm going to check for each of this number, all right, to see if it's a prime number. So 4, and I'm going to say, let's say short number that I'm taking in. I'm going to start at 2 as long as number is less than or equal to math should be capitalized because it's a class, square root, the method, and I'm going to pass in the possible prime. It's not an array. All right. So, and then I'm going to say number plus plus. Okay. Now, let's try to understand what we're trying to do here. We're going through the loop. We're trying to check every number from 2 to 1000. Every time we go to that number, we're going to do a little check in this inner for loop here. This inner for loop is going to try to use the base number, example 2, to see if this possible prime is divisible by any number from 2 to the square root of this number. And if it's not, right, if it's not, then it is a prime. All right. Now, what I'm going to do, I'm going to add a few things to make my life easier. I'm actually going to create a Boolean variable called isPrime, and by default, I'm going to assume, hey, yeah, it is true that this number is a prime number. And then inside this inner for loop, right? So because this isPrime variable is within this outer for loop, and within the inner for loop, I'm going to do a check. I'm going to say, hey, the number you pass to me, if possible prime, which is the number that I want to check, the possibly prime number, or the number that's possibly a prime, I'm going to mod it by number. And if I mod it and it equals 0, right? If I mod it equals 0, that means this number evenly goes into our possible prime. And if that's the case, then it isn't a prime number. So I'm going to set the variable isPrime to false. And I'm going to jump out this loop, which means I'll jump out this loop right here, break out of here, and go back to this outer for loop. But before it breaks and it goes continue into the outer for loop, and if there's any other code down here, it'll go to it. So I have a little check here. I say, hey, isPrime, the result that you found from this inner for loop, what is the result? True or false? Whether it is true or false would depend on what I would do next. Now, if it's true, then what I want to do is display, hey, I found your prime. I want to shout it out, hey, this is your prime number right here. Let's say possible prime, right? Possible prime, and let's do a space. Else I don't want to shout out, I want to do something else. Well, actually, well, in this case, let's just say I don't really need to do anything else. I just want to shout out, hey, I found a prime. So far, let's run this and let's see how all of this works, so we get a visual on all of that. So the program being compiled. After it compiles, right, and then it displays the work. So as you can see, the very last number is 997, and the very first few numbers is 2357. Voila! So we have found our primes, our prime number from 2 to 1000. Here we go, 2357, right? Just to verify, went to a site called mathisfun.com/prime numbers. That's where I found this list right here. So I could verify my code, my work, to see if it's correct, right? Just because you type it out, you code it, you run it, you can't be sure it's correct, it's accurate. Always verify your code, your output. So anyway, so I verify and it matches this. So that is good. That's great. But I'm not exactly done yet. Next thing I have to do is actually display 8 prime numbers per line and separate them by exactly 1 space. So I already actually did separate them by 1 space so you could see them. Now I just have to display 8 numbers per line. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so up to 19, new line, 8 numbers, new line. So what I'm going to do is create another variable up here. All right, I'm going to use short. I'm just going to use line counter, and I'm going to set that at 1. Okay. And for line counter, what I'm going to do is, instead of displaying this right here, I'm going to do a check. I'm going to say, hey, line counter plus plus modded by 8, and if that equals 0, well, then I'm going to print that out. Else, then I'm going to print this in a new line, right? Hopefully that makes sense. So you check if it's a prime. Yes, true. By default, it's true that it's a prime. It will only be set to false if the case is that this number, this possible prime modded by number, is this number evenly goes into possible prime. Then I'm going to say, no, this isn't a prime. This does a check. Hey, oh, it's not a prime. Okay, I'm not going to print this out. And this for loop starts over again to the next number. 2 becomes 3, 3 becomes 4, 4 becomes 5, right? For every iteration that it goes through. And for each time it does that, it creates another new prime variable. And it sets it to true all over again. And only gets set to false if it ever enters this if case. But if it doesn't enter this if case, it'll stay as true, and it'll go into this true, and it'll run this, right? Now for the line counter simply say, hey, if I mod this, which is originally at 1, if I mod it by 8 and it equals 0, as in 8 evenly goes into line counter, the value of line counter, and it equals 0, then display the number. Otherwise, no, what am I saying? If it evenly goes into 0, no, oops, made a mistake. If it does not evenly go into 0, display the number on the same line. But if it does evenly go into 0, display the number onto a new line, right? Onto a new line. That's why I have a print line right here. All right, so let's run that and give that a try. And here we go. Oh, perfect. That looks fantastic. So right here, I have 1, 2, 3, 4, 5, 6, 7, 8, 8 numbers here, 2, 4, 6, 8 numbers here, 2, 4, 6, 8 numbers here. So that's 2, 4, 6, 8. All of it is like whatever by 8, right? 8 columns, X amount of rows. And if you just want to make it look a little nicer, simply use string builder, and then use the what was it? The String.Format. All right, so what I'm going to do is inside here, just to make it look a little nicer, say string builder. Let's just call it our string builder prime number equal to new string builder. Inside here will be a string.format. And if I remember correctly, it was like %03, 3 for 3 spaces of in front of the D, in front of D for the decimal, and the decimal, the value will be the possible prime, and then this. So I'll just put this here, and let's take a look. Let's see if that is correct. No, it's not. Let me see. I think it was lowercase d. Lowercase d. Okay, there we go. So lowercase d, and all it did was just put up to 3 zeros in front, or it takes up to 3 space. If there's empty space for this decimal value, concatenate up to 3 zeros to it, or concatenate up to 3 zeros if there's no space, if it doesn't take up any numbers at all. All right, so with that, makes it look a little nicer. And yeah. All right, just to quickly go through it again, just one last time. Our goal here is to display all the possible prime numbers between 2 and 1000 inclusive. Display 8 prime numbers per line, and the numbers are separated by exactly 1 space. So right here we have all our prime numbers from 2 to a possible 1000. Unfortunately, 998, 999, and 1000 are not prime numbers, so they're not displayed. All right, display 8 numbers per line, separate by 1 space. And how to do this? Well, first thing we do is create an outer for loop that goes through the number from 2 to 1000. And then we check for each number that we pass this possible prime, check if that number is divisible by 1000. I'm sorry, is divisible by any number between 2 to the square root of itself. And if it is, then it's not a prime. If it isn't, it's a prime. And if it's a prime, display it. So just simply like that. And that will be it for this exercise.